Strings is a big structure, a huge piece of iOS development, any type of development, whether it be from Python, C, C++, Objective-C, regardless, strings is a big part of programming. We dealt with strings yesterday. We'll continue talking about strings today. And we'll also be looking at navigating Apple's documentation and getting used to it during that lecture. And also during the arrays lecture, we'll take a look at documentation, how to go ahead and navigate documentation and get comfortable with it. Because that's also an essential part of being a developer, going through the Apple documentation. So strings part 2, as promised, I want us to revisit one of the lab questions. We had a question where we had to switch on a string and add an additional condition on it. So we'll do that example, and we'll keep going there. Awesome. So the question was such that it asked, it was given a string, switch on it, and print all the characters if it is even, and print every other character if it is odd. That's basically the question, right? That was basically the question, yes? Okay. May not be word for word, but that's like the basic gist of it. So as we're reading questions, we have to take a look at what the question is asking for. It says switch on the string, right? Or in that case, given a string, switch on it, right? Switch on it, switch. The keyword switch there. So given a string, use a switch to go ahead and write the logic for that answer. So let's start out by declaring some string. I'll have a message here. I will use a string literal. Again, string literal is the two quotes here. And I will say good afternoon, or just good, good afternoon for now. Okay. And we also saw how to count the characters in a string yesterday. So I could say print there are, using string interpolation, there are message. Anybody remember how can we find the length of the string? Count, right? So dot count on the string. So message, thank you, that count here. So there are X amount of characters in the string, in message, right? And at this point, let's run our playground. And we see there are 14 characters in the message. Everybody with me? Yes? Almost? Okay, if our playgrounds are behaving, we should have, there are 14 characters in message, or in the string, rather. In the string. Everybody got that? Okay, so we're able to declare, initialize a string literal, good afternoon, and we're able to say how long it is, how many characters in it. Excellent. Now, is that even or odd? I'm sorry? It's even, right? We could write a simple case here to see if it's even or odd. We could say if message dot count. Anybody else wants to help me? How can I find out if it's even? Yes, Tiffany?
If message dot count on the 2 is equivalent to 0.
Everybody sees that? So if message dot count, in that case, it's 14. If 14 evenly divide, if 2 evenly divides 14, meaning there's no remainder. If there's no remainder, that means it's even, correct? With 2 here. Everybody with me? Okay, so here we'll just print a simple message saying string is even. We'll use an else in the case that is odd. Print string is odd. We'll test our code by running the playground again, and we see string is even. So far, so good. Okay? We haven't solved the problem yet, but we're just going through different cases of how to use and verify that your string is even, how to print a string, how to get the count of a string. And now we're comfortable with that, we'll go ahead and we'll use our switch statement. Any questions? So the mod operator, as we see, it's a very powerful operator in the language. Excellent. So let's keep going. So now let us solve our problem. Solution for question above. We'll start out with a switch, and we're switching on message. And we'll say kiss message, like we've always done before. But here we have a slight addition to this case here. On a switch, you could also have where on it. We've seen where with loops started Monday. We'll see where now with a switch. So I could say, hey, for that case, also have a check. Because remember, where also checks, correct? I could have a condition on my where clause. So here I'll have case message where message that count mod 2 is even, right? We're not lost yet. Colon, so everything in that same, sorry. So the colon is the last one, right? Because we're not done here. We're saying case message where message that count is even, using the mod operator. If it's even, the question said go ahead and use the for or use some sort of loop to go ahead and print all the characters. So we'll do just that. So we'll say for char in message, go ahead and print all the characters. I'll also use the terminator here so we know the use case of it. I'll print everything on one line. The question did not ask for that, but it's easier to see our string on one line. So I'll say terminator. I'll override terminator, because by default, terminator is an end line, correct? We said terminator is an end line. If we have time today, I'll show you a few escape characters. End line is one of those escape characters. Okay, for now, let's just put a comment here at the bottom. Say open quotes, \n is the end line escape character. We'll come to it later as time provides. But basically, an escape character has a \, on it. Right? So in our case here, this is a \, followed by the escape character n. N line. Okay? We'll see how to use it later in different use cases. Okay? All right. So we'll come back to that. So here we have a terminator, and we'll simply have a space. So instead of having an end line like this, we have a space. So by default, terminator is an end line. This is how it looks. We don't see it, but that's how it looks. Actually, we see it in playgrounds, right? If you see on your preview on the left side, that end there, that we don't see in our print statement, in the console, is that escape character. That's why we do not see it when we print. It's escaped, right, by the compiler. Anything that's escaped, you don't see it in the print statement. All right, so here we have for character in message, print character, terminator, meaning print everything on the same line. So this is handling our even case. So far, so good? Okay, cool. Let's go to the default case, because there's only 2 outcomes here.
So, all right.
Yes?
So for the switch,
Well, the question, we're doing what the question is asking. The question says, hey, if it's even, print all the characters. But we have to use a switch statement, correct?
Because it's asking for a switch.
Exactly. So we have our switch statement, and on the case, we have two cases, or we have two outcomes. Either it's even or odd.
Mm-hmm.
If it's even, we print everything. We have to check to see if it's even first by using the where.
Okay.
Right? So with the where, we know it's even. So far, so good. If it's not even, it's odd, correct? If it's odd, do we need to use the where clause? On the default statement, do we need to use the where clause? No, right? Because now we have to basically print every other character. In the default, we need to print every other character using a for.
Okay.
Were you with me?
I'm with you.
Okay, very good. Everybody else, we're good? Okay. So where is very powerful, and I wanted to show you guys how to use where here with a switch statement. Yes?
Okay, so in something like this, you can't use if,
Well, if the question asks you to use a switch, you should be using a switch.
and the switch would.
The switch is this on line 18, explicitly use a switch statement.
No, I mean like you can't use an if statement inside.
You can.
Instead of where.
Yeah, you can. But I wanted to show you guys how to use where as well. Yeah, that's fine. Yeah, that's good. Good question. So yes, you could use an if on a where. Okay? But we're using a switch, and within that we have our where. But you can have an if too instead. Cool. So now we have our default here, and the default says for char in message. Clean that up a little bit here. Great. So now we want to print every other character. We'll use what we saw yesterday. We'll use enumerated. What does enumerated give us? It gives us the index as well, correct?
Yeah.
All right, so now we have the index, so we need to update this. We have the index. We have the value. Great, so this is good. Now we want it to only execute the body of the for if the index is odd. Okay, you could use an if inside the for statement, or you could use a where outside. Everybody with me? You could use an if in here, saying if the thing is odd, print it. Or in our case, we'll use a where here. We'll say where index mod 2 is what? 1. Right? If it's 1, it's odd in that case. Go ahead and print. Print char, and we like our terminators, right? And we'll do the same as the top. We will print everything on one line using the terminator with a space in between. And when we're satisfied that everything is okay, we will run our application. Oh, you see, so I still had my end line, and it printed vertically. We see that? So I need to remove that. So just keep in mind, this is end line, but if you want space, you need to explicitly say space here. Run it again. Okay? So everything got printed. That means it was even, correct? Everybody with me? Everybody with me? Right? Because we confirmed that our string was even when we used the count earlier. In the if statement, we said if even, print is even. It was even. So now it got into this case here. It went into the for on line 21. And it's printing all the characters. Good afternoon. The whole thing got spelled out. Everybody finished typing? Is there anybody still typing? Okay, so we'll 30 seconds, and then we'll go up and change our string to odd to see what happens. The switch is message. I'm switching on message.
So the case is in the case of message,
Mhm.
that's how I'm saying it. So in the case of message, where the message count, meaning the characters of the message are well, divided by 2. The total characters in the message divided by 2 gives you a remainder of 0.
Meaning it's even.
So in the case of that,
Mm-hmm.
for each character in the message, print the character.
Correct.
Now, else, or
Mm-hmm.
if it's not even,
Default.
for the index, for wherever that character lies
Mm-hmm.
in its, I guess, in its form, I guess you could say, or like in message, wherever that character lies in message, or whatever that message is, wherever that character lies, where, okay, where's something, okay, so wherever that character lies, where that index
Is odd. Only print odd. That's what the where is doing. The where is this sort of clause, right? Like a restriction.
Okay.
Only where this is true.
Okay.
Only where this is true, I enter the for loop. Everybody with me? Where explicitly says only where this condition is true. Only where this condition is true that you execute the print statement on line 25. All right? That's why I want us to see where more, because we're comfortable with if else so far, but where we haven't used too much of. So, yes, sir. Okay. Yes. Doesn't create it, but it exposes it for you. Enumerated exposes the index, the current index for us. So now we have access to it. Exactly. Or use it whichever way you want. In our case, we needed to use index to see if the index is odd. After 4, what line number? 24. Index. This guy here. That. So when you do dot enumerated on any collection, everybody, when I explicitly say dot enumerated on any collection, it gives me access to index, the current index of the collection. It starts at what number? At 0. So now I'm able to, whatever name I want, I could call it I. In our case, index is a better name because it's the index of the array or the index of the string. So I say index here, I could give it any name. Same as we have our regular for loops. We could have the variable name be any name. Var, we do not use var as we said earlier. Var is implicitly known by the compiler. It's a let already by default. Right now you can't change what index is. Yes, like the index itself, you can't say, oh, index equal to something. You can't assign index anything. It's a constant. All what you have is what it is. It starts at 0. Every time it enters the for loop again, it increments. So 0, 1, 2, 3. So as it's doing that 0, 1, 2, 3, the where clause checks. At 0, it divides it by 2. It's even. It goes to the next one. If it's odd, it doesn't print it. Oh, sorry. If it's odd, it prints it in our case. We only print odd numbers, odd indices. Yes?
Okay, so for the first one, it says...
the first one. What's the first one?
Like where it says case, right? For
what?
char, for...
Give me a line number.
Sorry,
20.
So it says for char and message. That's saying like for the total, like for the total...
For every element.
Yeah, for every element.
For every element, for every character in message, print it.
Right.
That's why, Eric, on line 20, we're not explicitly saying dot enumerated. We do not care about the index. We want to print everything out because it's even in that case. Because that's what the question was asking. Print all the characters.
Right, and then for index / character, that's like saying, but for each specific...
I'm concerned about each index.
Okay.
Because I want to know if it's odd or not.
Okay. So for the whole message, print this, but for each specific index, print this.
For the whole message is 20.
Right.
Print all the characters.
But once you put the index character, that means you're breaking it up. Each one is individual.
I'm not breaking it up, but I'm interested in using the index.
Well, when I say breaking up, I mean like you're interested in each specific
Yes,
index.
yes, exactly.
Okay.
Exactly. So for example, if somebody tell you at index 5, do not print it, The only way to get to so for 20, for example, if the question asks, at index 5, do not print that character, there's no way to print it now because you don't know what the index is.
But once you put enumerated,
You have access to that. So I could say if equal to 5, don't print. All right? Yes, Yuba. Yes, you could do either or. So Luba is bringing up a good point. The question said every other character. It's up to you at this point what every other character means. Okay, for sense of clarification. But if you are an interview, you'd ask the interviewer, do you want me to print every odd character? Do you want me to print every even character? Because it's a bit ambiguous, if that makes sense. So at that point, you want to ask for clarification. Okay? Exactly. Exactly. Anytime you come to that, you could ask us, obviously, because we wrote the questions. But when you go to your interviewer, definitely you want to ask for those things. Yes. Yes, I will get to, I have a section on escape characters, but I'll show you what it does. It's better to show. Cool? All right. Yes, sir.
In this question, it's saying print every like if it's on, it's on. But in this case, this is going to start from 0.
You could make it even if you want.
But 0 and 1 is going to be
Well, it's every other character, right? So if I skip the first character, I want to print the other character.
Yeah, I mean, but this is cool. Like, it's starting from 0. 0 is not going to be on by 8, and then 1 is not going to be on by 2 as well. So it's
Let's see what happens, right? So let's print it. Did we print it yet? Let's run and see what happens. Oh, we didn't change. Sorry, I gotta change my, make this odd. Okay, let's run it. Thank you. Okay, so here we do not print the first G. One second. It skipped G, it printed O, it skipped the other O, it printed D, it skips.
Real question is, if you reverse it, you put forward into print. Like if you reverse, you skip every other one on even, right? It's going to skip one answer, right?
But in our case here, we want to skip the first one, right? We skipped G, we went to 0. Eddie? We skipped G, we went to O. We skipped O, we went to D. Okay?
But now I am a little, because technically, right, when we're doing, can we go back up a little bit?
What number?
To the same one. So it doesn't consider, I thought that spaces are considered characters as well.
Space is a character.
Okay, but it's not considering the space as a character, because if it's considered as a character, it would be more than 14, no?
Where am I here? So let's do a simpler.
Because good afternoon is 1, 2, 3, 4.
1 second.
Right? And then afternoon is already 11, 12.
Let's do bad and let's see what happens. Let's do a shorter test case. Okay, guys, it's easier to do a shorter example with this particular example. We have the string bad. It skips B, it prints A, and it skips D. I'm done. Every other character.
Okay, so then let's say you put a space, right? And then put B-O-Y, bad boy. Then you should print A, space, O.
So let's see. So it skips B, it does A. Skips D, does the space. Skips B, does O. Skips Y. Everybody? Okay? You're not going to see the spaces, right? The spaces are not there on screen, but count it as you go through it. Thank you for the questions, but one of those is like you have to take it to paper and see what's happening. Yes, sir?
So then how would you start it at printing at D?
At B?
Like printing, like instead like printing every other.
All right, let's see.
If you put an if now statement like
Let us swap it.
that's equivalent to 0, then print, and then you just have to put another you
So what do we have? We have B, right? We have B. We have uppercase B. We skipped A. We have D. We skipped space. We have B. We skip O, and we have Y.
So zero.
We just swap it, yeah.
So the index zero is even.
Like it keeps us correct. Like all what we have to do is toggle our even to odd, right? Everybody? Okay. It depends where you want to start. You flip your even to your odd. Okay? Any more questions? Any more questions? Okay. We are good, correct? Everybody has the code? Everybody has the code.
Yeah.
You could get a question like that on some interview, trust me. That is a fair question. So knowing how to manipulate using where or if or whatever, knowing your mod operator is very important here. You had a question? Oh, I thought I saw your hand. Correct. Kelby. No, you're good? All right, cool. Okay.
Is this trying to ask other questions or no?
Yeah.
Just one question. Okay, for the question with
Oh,
the rows.
questions we'll get out offline. I wanted to show us the questions where I wanted to make sure that we know those. Like the row question, we'll do that offline.
Okay.
All right, very good. I want to show us the escape characters before I miss it here. So let us create a new heading here. Well, we had no heading to begin with. Where am I? So this is fine. We'll start a heading right here. Yeah, don't hesitate to ask lab questions offline at any time on Slack, which people are doing already. So you could always message us, whether it be on the channel, message us directly, either way, whatever works for you. So don't bottle a question in, put it out there. Cool. Okay, so let's look at a few escape characters. There's more. Yes. And I think the technical term is control transfer statement. So Amini was asking what's the terminology, what is it known as? So where along with continue break, those are considered control transfer statements. We started doing it on Friday. So control transfer statements. Okay, so escape characters, we will look at just a few of them, not too many here. We will look at example, the big one we've been talking about is new line. And we'll look at tab. Tab is the same when you press tab. It's the same. So it's as if you're pressing tab. But it's an escape character. And if you want to escape, for example, for some reason, you want to escape a quote, you also use the backslash with a quote. So it's actually part of your print statement. All right, let's see that in a demo. Okay, great. So let's start out with some strings. So the last one is just a quote. So this one is, let me put names to it. So this one is new line. This one here is tab. And this here is a quote. It's the regular 2 with, 3. So the regular 2, backslash first, and the one you want to actually show. So example, new line. New line example. Let's create some, we have message already. That's fine, message 1. Hello. Depending on if you want to compare them, yes. If you want to compare uppercase H with lowercase h, then they won't be equal.
No, I mean for the.
Oh, yeah. So it's all lowercase. Yeah, thank you. Okay, so we have hello iOS 6.3. Great. To have you! Exclamation mark. And here, you see it's already complaining. Every time you try to do a backslash like that and you don't give it a valid, it's good that that actually came up. If you don't give it a valid escape sequence, it's going to give you an error, invalid escape sequence in literal. Because what are we doing here? We forgot the N. Everybody sees me? Okay, so here we need the N here, and here we need the N here, and then the compiler is happy. So what are we doing here? We have hello, new line, iOS 6.3, new line, great. I don't need that there, thank you. Great to have you, right? Everybody with me? So how many lines do we have here? 3 lines, right? And they're able to break up because we have explicitly said at each one, I want to create a new line at that particular character. Okay? So within your string literal, you could have new line characters in there. You could also have tabs in there, but we'll do the tabs separately. So now let's go ahead and print our message. Let's print our message here. And, oh, let me fix one thing. Again, glad that happened. If you're doing Terminator on one line and you forgot to basically close your Terminator or add an extra new line, this is gonna happen. You see like how we have hello here on the same line as before? So now I wanna break it, I wanna have hello on its own line. Good that we've seen new line. We could actually just add a new line here. I could add a new line right here. Do we see the console here? Right? Do we see the console where BDBY is on the same line as hello? Right now, I'm going to break it using a new line character, run the playground again. And now my hello is on its own line because I used the new line character right before the H. It's not part of the print statement. Everybody with me? It's escaped. That means it's escaped, it's not part of the print statement. I do not see \n here, right? It's invisible to our eye. But the compiler sees it. The compiler is able to recognize what it is. Cool?
How do you do that
In the Terminator.
Do you add to the Terminator statement?
The Terminator statement, we give it one character, right? Like what the Terminator is, right? Whether it be emoji, whether it be new line, whether it be a dash, right? You with me?
Yeah.
So right now, what happened, we had a Terminator before, and that kept going. And it also took our hello. So I wanted to break the line, start on a new line. So I added a new line right before the H. Right before H here. This is new line character. Greg, Kelby, does that answer your question?
Yeah, but I was just curious how you do that. Can you do that within the Terminator?
Oh, what you could do, so let's take this out. Wherever we had our Terminator here, over here, I would do, in that case, you probably have to do an if else, like we did with the skull last week. But to keep it simple, you could simply put a print statement here, an empty print statement. And that creates a new line, okay? Or you could do what we did. Cool? Many ways. So if I run it again, Kelby, it's gonna work as intended, where we have hello. See that? Yes, because we broke it up. Yes, Andrea?
When you do multi-line strings, does it print?
Multi-line strings, we saw, it prints as is. So the multi-line string we were talking about, so let multi-line equal to multi-line. This is the syntax. Everybody remember? There's 3 quotes, so I could say, hello, it's hot out today, right? And if I print my multi-line, it prints as is, right? So it prints the 3 lines. So if your question was, does it do the same thing? Yes, it does. Cool? So Andrea's question was, does multi-line do the same thing as using the new line in that case? Yes, it does. Everybody with me? Okay, cool. All right, I want to talk about initialization a little bit. We'll get more into initialization but I want to talk about it a little bit here with some context with some of the lab questions we had. Siri, leave me alone, please. Okay, so string using string initialization methods. So using string initialization methods. We had a question yesterday, use string initialization to create an integer or a character rather. So let's see what that looks like. So the question was, use some type annotation here. Declare a character, initialize it. In that case, we'll just say A here. So this is a character, correct? This is a data type character. This is a character data type. We have to explicitly type annotate it with character, right, everybody? If we don't type annotate it, what type would the compiler think it is? A string. So here we're using type annotation for this variable char here. And now we are going to, as the question was asking, initialize a string using a character. Now, if, let's backtrack here, start typing the word string, G, open parens. So type the word string, open parens, and your compiler should give you some default initializers here. Do we all see it on our screens? Okay, so we have bytes, we have character, we have characters, we have code units. We have, you could create a string from a URL, right? There's many ways you could create a string. Initialization is the creation. We've seen get init, get initialization, get init, right? Create something for me. So if I want to create a string, there's many ways to create a string, right? The list keeps going. String is huge, right? So let's go back here. So look for the one that says string from character. Do we see that? String C, character. Double click on it. And now it expects a character in the parens. This is an initializer, a string initializer that takes a character. Right now we could pass in char. And what type is our string now? Our str variable? It's a string, right? So if we option click on it, it's a string. We use a string initializer to create a string from a character, okay? So that's what the question was asking for that. And you have to keep in mind, we have to our disposal type of. Anytime you want to know what type of variable is, very similar to JavaScript, we have a type of. So type of this variable called char, what type is it, right? The compiler will tell you when you run it. It's a character. Do we all see character in the console? Cool? And let's see what type our string is. Yes? It depends. Maybe you want to loop through a certain collection of characters and you want to create a string from something. Right? So now you have a way to do it. Cool? That's one way to do it. We've seen other ways to do it, and I'll show you again one other way to do it, so we are on board. String here. Okay, so that is initializing, not here, but here. Initializing a string from a character. Okay. We could also initialize a string from an integer. So initialize a string from an integer, from an int. So here we have current year. string word, and the current year is 2019. So now our type, with the option click it, it's a string. And this is an integer. Everybody agree? Okay. So all those pieces here we could take to our text adventure as needed. And now we could simply say print current year is string interpolation here, current year. And we print it. Current year is 2019. So int to string is pretty simple, but vice versa, we have to deal with optionals. We'll see more optionals on Friday, but we won't get into optionals right now. We'll go to our favorite topic of the day, string index. We love string index, correct? Yes? Yes, okay. Scroll up a little bit. Is that good here?
And is the second one in reverse where?
The second one, what? Give me line numbers.
55.
55. 55 is basically doing what the comment is saying. It's initializing a string from a character.
Okay.
Let me split that up there a little bit so it's easier to understand.
So the first one is initialized.
The first one is declaring and initializing a character. This is not a string. This is just, well, it looks like a string, but it's going to be a character at the end when we assign it to the variable by using type annotation. And let me just tell us again here, we have to explicitly use type annotation to get a valid character data type. So many things. Yes, sir. Yes. Andrea.
Can we look at that, like, how, what we use, it's called casting?
For the integer?
Yeah, like how we did when we tried to make a float with them.
A float to a double, you mean?
Yeah.
Let's do it at the bottom. I think we have time, maybe. Okay, so what we had some result, right? And let's backtrack. We have a float, correct? And we said it's a float, happened to be float. And we said it is whatever, some number, correct? And we started saying we have a double, call it double. And it's 45 point, whatever, 112. So far, so good? So we know, well, first of all, we don't have to do this double. Everybody agree? We don't have to explicitly say double here?
No.
Because the compiler infers it's a double? Yes? Okay, now we have, I'm sorry?
I would say that you have to say that it's a float. What's the word again?
Float.
No. You have to
Type annotate. Remember that word on the interview, before the interview.
You have to type annotate that it's a float because they would assume it's a double.
Exactly, very good. So Andrea's question was just to review how it's done. So here we have a result variable, and we are attempting to add our float plus our double value. Right? Is that the question, Andrea?
Well, I was saying, like, I kind of think of it how we're doing it with the string and character.
Oh, but we're not, let's see.
Because we had an example.
Yeah, it's very similar. So that's like casting to the type. But instead of casting here, it's an initializer. So that's the difference, right? The initializer is part of that type, right? But if you want to convert one type to the other, then you cast, right? It's not an initializer. It's a cast. It's casting one type to the next. Yes?
Now, what's the difference between reading that current year equals 2019 You
mean remove this string here?
Yeah.
To show you how you could convert an int in place into a string.
Yeah, but the string would
Sorry?
so you have to put the word string before it.
Yeah, to convert it. So this converts the string. Yes, you could type annotate as well, as opposed to doing all that. You can. I could put 2019 directly in there. All right, but now, exactly.
So now, that's what I'm asking you. What's the difference?
The difference, it depends on the use case, right? If you want to use that variable, maybe you took that variable from the user, and maybe it's an integer. Maybe you want to convert it to a string, but you're getting a string already. Not a good use case there. But say you're getting a string from some database or whatever, you want to convert it to a string. This is not heavily used, but you want to know how it looks. The easiest way is the way you're pointing out. You have the integer, string interpolated, you're done. Okay? But we have to show you all the ways, or some other ways to do things, in order that way it's not surprising to you. Like, hey, I've never seen that before. There's a lot of things you're not going to be able to see here anyway, but we want to show you the commonalities of what you could see in the industry or in code bases. Okay, so let's see here. So we have a double here, and now we're going to cast it. It's not a, we're going to cast it, Andrea, right? It's not an initializer, okay? A little different. It's not guaranteed to give you that value, as we saw with response and the integer. It's not guaranteed when you cast to get the type you're looking for. Okay, so here we have our result. It's going to print result as we expect it to be, whatever that result is. Okay, awesome. Oh, that's good. I'm going to show something else first. So now we have 68.67999999, and that doesn't look good on an app. Everybody agree? Right? We want to make it look more readable, more better on the eyes, right? So we want to say 68.67. I'll show you guys how to do that using string formatting. So that's our next header here. Thank you, Andrea, for that one. It's never a tangent. Tangents always come back. Okay, so here we will see string formatting. There's many ways to do string formatting, but this is just string format example formatting decimal places. Okay, so we have our result up here. We know where the result is. This is great. So now I want to format my result. I'll simply say print the result of the calculation above is, comma, string format quotes percentage sign dot to f comma and result. Let's see if we have any errors here. That is a bit weird sometimes typing it, but it does give us 68.68 from 68.67, right? It did round it off as well. This is very Objective-C. It's a bit better on the ICE, but that's like really Objective-C, right? Like formatting strings is like something Objective-C did really well. So you have the string that you want to print to the user here. The result of the calculation is, and here is the string format. Now that is an initializer using whatever format you want to pass in. So the format you want to pass in is within those quotes here. That's the format. I want to have 2 decimal places. So I explicitly say 2 decimal places. F is a float, floating number. Lowercase f, not uppercase f. Lowercase f implies floating point number. So I want 2 floating point numbers after the result. You could have 3, 4, right? Everybody with me? So this is the way to use string formatting on a decimal. With how many places you want? Yes. A full number? Yeah, you could just put 0 in that case if you don't want to. If you want to. Yeah, it would just be 69 or 68, whatever that was. Let's see. Let's see what the result. Yeah, let's see what the result is.
So you have to put it on a new line in order for it to work. You can't write it on the same line.
1 second. Zero had a question there. Let's see what we get. So we got 69, right? You see it? So Zero's question was, can we just get rid of the, like round it off to a whole number? So we have 0. I think actually you could remove the 0. I think it still works. Let's verify here. Right? You good? Okay. But normally we want to have 2 decimal places. Yeah. You're not taking the people money away, are you? Well, you could, actually, I'll come to your bank. I'll come to your bank. I'll come to your bank. I just need to get 65 and 50 cents, and I write at $66. Yes, sir. F, always F. Yeah, because remember, what actually we have a double here, right? That's a double. Result is a double. If you option click on result, it's a double. So on floats or doubles, the F is just implying floating point numbers, because a double is still a floating point number. Yeah, floating is just like decimals. Cool. Thank you, Andrea, for that one there. That took us into string formatting. I know we really love string indexing. Let's go back to it. Or are we trying to run away from it? Which one? Yes. Assuming like you're working with numbers, that's the use case for it. I do not want my app to show 68.67999. I want it to show 68.678 or 68 rather. On an actual string, you're not found. If you want to do a format on a string, that's something else you're looking at. Yeah, but that works with numbers. Yeah, there's different formatting that we could get into, but I rather share a resource for that. There's like a resource, like a formatting resource, very similar to like the cheat sheet I shared. Something like that you could have a look at, because there's a lot of them. Yes? I wouldn't be surprised. Let me slack it over to you, because there's a lot of, is it on the string format one? All right, let me slack it out, because there's a bit going on there. Okay, it's in the Slack. Cool. All right, great. So let us index in our favorite topic. We did start index yesterday. We did end index, but we haven't done a range. So let's do a range so I could actually sleep better, knowing that I showed you range. So creating a range on a string. You have a question? You okay, Sarah? Oh, okay. Let me Slack what I have right now. I'll Slack what I have right now so we're all on board. Strings 2, version 1, push. Okay, cool. So creating a range on a string. Let's create a string. Let message to self equal to I really love Swift, because I know you all do as well, and I'm passionate about coding, which I know you all are. Correct? We all are? Yes. This is a true statement, right? Anybody, hands up? Disagree? No? Okay. All right, cool. So we have a message here. Let's get the start index for that message. Anybody want to help me get the start index? From what we, what's that? Yes. So Amini volunteered. Go ahead. Okay, so message, very good. Message to self. Dot, very good. Give it up for Manny. Very good job there. So this start index, again, is the first position of that first character in my message to self string. The first position, right? So here we are getting the first position of message to self. Very good. Oh, fancy stuff. I'm showing you some more fancy stuff. Yesterday we saw, did we see offset? We did not see offset. We didn't see offset, right? Okay, sorry. So I'll show you guys offset. So here I'll just say offset to some character, offset to some char. To get an offset, I'll use, again, anytime you want to get any index, you have to use the message. Everybody with me? Okay, so here I will say message to self. I'll start typing in index. Let autocomplete help me here. Maybe. Index, not after, not before. I want to use the one that says offset, the third one here. Not limited by. The one that says offset, go ahead and press enter on offset. Let me do it again. I'll do it again. So type in message to self. Type in the dot. Everybody with me? Type in index, the full word. And your compiler should now show you the options you have on index. Yes? What's happening? Okay, so we're not interested in, let's go. So again, we're interested in offset. The one that says offset, that's the one you want to select. Mine is bigger, so you're not seeing the word offset. Not the one that's distance by, only offset. Index, offset, two parameters, two arguments. Let's do it again, not limited. You want the one that only says offset. So index, offset by. Everybody with me? Okay. You press enter. The start index we have, so the start index we have, we'll type in start index here. That's why it's good to create the variable, so you're not typing in. If we didn't have start index here, guys, we have to type in message to self dot start index. It gets even longer. You with me? Okay, so now offset, you could put an actual integer here. Like, where do I want to go? For now, we'll count where we want to go, but I wanted to show you a more advanced way. But for now, we'll count. Say I want to get to the end of Swift. How many characters is that? Let's count. 0. We start from 0, correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Everybody with me? I want to get to 18, so I put in 18 here. I put too many things here. Not enough space. 1, 2. This is gone. Okay. So right now, what we have is the offset to some character. That character, if we counted correctly, should get us to the end of our Swift, the end of our T. Okay, it might be 19 I think we may have counted wrong, but we'll see. So we have some offset number. We have a start number, a start index. We have an offset to some character index, actually. Let's name that better, because it's not the actual character yet. It's an index. Okay? It just gets us the index. Okay, now let's create our range as we promised. So let's create a range here. I just put 18. Yeah, the number we want to get to. But we'll see a different way how to get it, like some character that you're looking for, and you get that index. All right, but for now, we hard-coded it in. So we have a range that we have here, and we start with our start index. Start. Start again. Start index, dot, 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 and offset to some character. We want to get all the characters included. Remember, a range, we've seen ranges. Anytime you see 3 dots, it includes everything, correct? Inclusive from 0 to whatever 18 is. Exactly, exactly. So add everything, okay? That's the range. And now we want to go ahead and print our string. We'll call it substring. We're not printing yet. So substring here, again, we're using message. And now we could subscript. Again, you could only subscript on string.index, correct? You can subscript a string using an integer. If I attempt to do this, does it compile? Right? Swift will tell me, or the compiler will tell me, subscript is unavailable, as we saw yesterday. That's why we need, let me actually leave that again, so we know for our notes that does not compile. Subscript. When I say subscript, what is subscript? The open and close square bracket, correct? So does not compile, subscript not allowed using an int. Only works on a string.index type. Yes, I'm missing my P. Thank you very much. So does not compile subscript, does not compile subscript not allowed using an int. Only works on a string.index, right? So you could do subscript on this like that, but you can subscript here using some int. Any questions? Okay. So now let us go ahead and create our substring as we had above, using message, subscript, the string index. In that case now, we have a range. Right? That range is made up of string index, right? The range itself is made up of string index. And we could just say print substring is substring. I will scroll up. So substring is, I really love Swift, right? Everybody sees the print in the console. I will scroll up to make sure we all have the code. Let me know if I should scroll up more. Is that okay here? Is that okay here? Okay. So we created a substring using string indexes. We found the start index, which we saw yesterday. We also found some index that we want to go to, right? We call it offset to some character index. And we use those two indices to create a range here. This is a closed range. It includes the lower bound and the upper bound values. And we use subscripting on a string index to create this substring variable. And we used string interpolation to print it out. Mr. Python is not too happy about it. All right? But it becomes art after a while. Any questions? Cool. So good. Yes. Question. Yeah. You haven't put it together? Okay, when you put it together, let us know. We're here. Let's go to simpler use cases in life here. Let's get away from indexing for a while. Yes, sir.
Just to make sure I actually understand what we did, right?
Well, part of it is like doing it again and doing it in lab when you fully understand it. But ask your question.
So we did that range.
Let range. Okay, 86.
Yeah, so that created a start and body.
Yes, exactly.
And substring created a different sentence, correct?
Substring is only saying now give me the string from that range.
From the start to end.
Yeah. Exactly.
So it's used to create out to pull a sentence from.
Yeah, a substring from a string. Yeah. Exactly. Like say somebody give you some question like, hey, bring me back Swift from that string. Given this index and the offset is whatever, create me a substring. You could do it now.
Just a question, it doesn't, it didn't print the whole sentence I wrote to the question about it because we set it up at 18.
What did I do? I really love Swift. Oh, am I missing some stuff? I thought we had the whole thing.
That's what I said, how do you know this?
Oh, that's what we got here. So we counted from 0. If you count from 0, including the space.
No, I'm saying I was saying, when you chose the number 18, say you wanted to actually print the whole phrase, how would you?
Oh, if you want to print the whole phrase, you just say print message to self. Yeah. But if you want like a subset of it, you would have to go to a particular spot. Like say I want to only print love. I could. I need to get the position here, and I need to get the end position here, create a range, and then print it out. Okay? Does that answer your question? Okay. Yes, sir.
Is there another way to
Okay, pushing me there. We'll see more stuff. Okay, that's fine. So let's see. Mr. Eric is saying, can we get the position of T here? So let's get the position of T, and I'll stop here and I'll continue. But let's see how it is done. Okay? So say we want to get position T. Let's keep going here. I will actually create a new heading because this is very important. Thank you, Mr. Eric. I will say find or search for the index in a string. Search for the index of a character. Search for the index of a character in a string. Cool. We have our string already up here. Let's just make it smaller. I'll just take I love Swift here and bring it down here so it's easier for us to see. It's going to be a let Swift mess. I can, but let's just create a new one so it's like on one screen. Cool. So we have I love Swift here, and just put a heart. So it's not the actual last one. Okay. I really love Swift. This is great. And again, for the emoji, if you want emojis, it's Control Command Space brings up the emoji keyboard. So emoji keyboard. Control Command Space. Cool. All right. So let us get the character index. I call it character index for the variable name, and I say Swift message dot first index. So start typing in first and scroll down to where it says first index. That's not what I want here. I just want first index of character, sorry. So first index of character. Do we see that? Let's do it again. Come on. So start typing in FIRST index and first index of character. Do we see that? Yes? Swift already infers type inference. Very good language. It knows what type you have, so it already says, hey, whatever you're looking for, it's a character. So that's why it fills this character in there. Later, when we see our own custom types, we'll see our custom type in there. But for now, this is a character, so find index at character. And what we're looking for is T, right? What does it return? Optional. We love optionals. Remember I promised that optionals is everywhere in the language? There's one use case for it. Because the thing might not exist, right? The only way for Swift to tell you it doesn't exist here is return an optional. Did we option click? Make sure you option click on character index. Did we? What type is it? String.index optional. It might not exist. Preview again for Friday. Review from last Friday. Optionals. They're great. Awesome. So here we have an optional. And let's see, what should we do? Give me one way we could unwrap this optional. The names. Give me one of the types of optional unwrapping we could do here. Nil coalescing, right? As Ian is saying, anybody remembers what nil coalescing is or the syntax for it? Yes, so Tiffany is saying the 2 question marks. Very good. We do not need an optional class on Friday, right? Okay. Okay, so the 2 question marks is nil coalescing. Right now, we're telling the compiler, we're giving you a default value, if in case the value for T does not exist. Everybody with me? Okay, so we could just give it a default value here. The default value needs to be of the same type. So the default value here we will give it is string.index. Well, not string.index, it's not going to be happy here. We will give it message to self.startIndex. If you give it like 0, let's do that. So if you give it 0, let's just comment that out actually. So Amin is saying if I give it 0, will that work? So let's test. Again, the best way is to test, right? So if I give it 0, what does the compiler tell me? It tells me cannot convert value of type int to expected argument type string.index. I'm expecting a string.index as the default. Why? Because whatever I'm looking for is data type string.index. They need to match. That's why when on Friday we give it -1, which is a valid integer. Okay? Everybody with me? Whatever value you're expecting to take out of that box, right? If it's a teddy bear, you gotta give it some default teddy bear. You can't give it a bird or a snake, right? The snake might actually bite you. You have to give it that same data type. So here we want to give it message self.startIndex, which is also valid. Great. So now our character index, if we look at it, what type is it now? Which one? Which one? Oh, you mean like the dialog box? Oh, okay, that's fine. So option on your keyboard, click on option and click on the variable name. The mouse is a bit hard to get used to at first. What type is it now? Is it still an optional? It's not an optional anymore, correct? Because we've given it a default value. Regardless of what comes back to us, it will be either the valid index of T or the default index of message start index. Everybody with me? That's what nil coalescing gives us. So right now, there's no way our app crashes if we try to use this value. Cool? Everybody with me? Okay, excellent. So now I could just print, or rather, I could actually print. No way to better see stuff. Found found message. Oh, guys, tell me I'm not confusing you. This should be Swift message. Yeah, yell at me when I'm doing things like that. So here we found Swift message. The index is character index. Found whatever in Swift message string. Right? So here we have a print message saying we found whatever character it is in Swift message string. Or rather, we found oh, let's see. If I put, actually, that's going to be a good use case. Maybe. Actually, that's not. Okay. So we found whatever character in string index. Actually, that's a good use case. That is a good use case for our escape sequence, which we promised to show, and we did not yet. So let's escape. Right now, we have an error. We need to escape our quotes. Remember earlier, we need to go back to that, by the way, so many things. We showed us new line, correct? We said we were going to show tab, and we said we were going to show quotes, according to that headline. But we got diverted. That's fine. We'll come back. But now we have to escape the quotes. Because the compiler says string interpolation can only appear inside a literal. It's getting confused. Because right now we have quotes everywhere. Right? So put a backslash, not delete. Put a backslash where you want to escape the quote, before the quote, like this. Gets a little more confusing. Let's start over again before we jump out the window. Don't jump out the window. All right, this is what we had. We found whatever in Swift message string, correct? And we want to be fancy. We want to put quotes. We want to put the T between quotes, correct? Everybody with me? We've seen where we want to go. Okay, so if I attempt to do it, I put a quote here, and I put a quote here. The compiler starts seeing it. It's like, hey, I'm trying to read a string. I see we found as a literal. Then you have this string interpolation. I'm very confused. Like, what are you trying to do? Right now, we confuse the compiler. So we need to escape those inner quotes here. We escape it using what? The backslash, right? As Melinda is saying, we escape the quotes by using a backslash. So right where you want to escape the quote, you put a backslash. The compiler is still not happy. Why? We're missing one backslash, right? So we also need to escape that second backslash here. At this point, the compiler is happy. It's not seeing the quotes as part of the syntax. The quotes now is part of the string, right? Everybody with me? Yes, sir. Yes. So as Greg is saying, the idea is to put the backslash before the character you want to escape. Okay? All right, now let's go ahead and print. And we have, like we wanted, we found T in Swift message string with the quote still there. Do we see that? Yeah.
So, after the,
Oh. Where am I? What line number? Oh, right here. Here. We're looking for the character T. Because first index, it's expecting the argument to be a character, and that character can be without quotes. So that's what it is. Cool? Like we could look for the heart as well. I could look for a heart, right? The heart. Heart. Right? I could also look for a heart. Let's run it. Let's see if it's found a heart. It's found my heart. I could survive, right? But if my heart is not there, for example, my poor heart is not there, it's trying to find some flame, right? What's going to get printed? Very good, very good, very good. So, as Amini, Tiffany is saying, and the rest of us, what's going to get printed is I. Why?
Because that was your
That was my default for my coalescent, right? Sarah? That's fine. So why I? Because here we are trying to say, using an optional, first index, find the flame.
Oh, so there's no flame.
There's no flame, so go ahead and show me the first character on myself.
So that question mark says if.
Exactly. So as Zara is saying, the question mark implies try something. If not, do something else. In the something else, it is just show me the start index of my Swift message. Yes, but let me go back to my heart. I love my heart. Okay, cool. They're string indexes. Just think of it. They're numbers per se, but because of the way Unicode is complex and the way characters are complex, they can be one-to-one. Because as we said, a character could be one or more Unicode characters, right? That's why it becomes difficult in Swift to do what Python is doing with numbers, right? Because the character itself is not one, right? It could be more. Okay, cool, good. Okay, let's see some simpler things on the eyes here. Get away from Swift string index a little bit. But it's very important, guys. Knowing how to manipulate strings using indices is very important. Yes?
I'm just going to a question. So when we have substring is, and then the backslash on substring, when we said let substring on, well, for me it's one thing, but I think for you it's further. Let substring equal.
Let substrings. This guy?
Yeah. Oh. Okay. Well, range is the start index with the offset. Okay.
Nice, nice, nice. Good, good, good. Very good. Okay, let's look at some.
Oh, and it's a range of the three. Oh, okay.
Wow, getting everything. Love it, love it. Okay, so let's look at suffix and prefix. Yeah, suffix and prefix, that's fine. We all know prefix is like the first set of characters in some sentence. The suffix is the end of the sentence, whatever character you're looking for. Swift strings have prefix on them. You could prefix something and be like, hey, does this string start with str? Or whatever characters we have in that question. Let's create a variable and see what we're talking about. So here I will have, we haven't used name here, but I'll put name here. And I'll say Alex in that case. And we could use prefix on this string. So if name dot has prefix, right? If name has prefix, this is a function. Let's stay here. Let's go over this. So let's backtrack. So type in has, pre, prefix comes up. Let's go over this step by step. So M, do we see the M? M implies method. We'll get into methods, functions later. But M here is a method. Bool, do we see bool? Bool says this is what the return type is. This function returns a bool, true or false. Prefix here is a parameter name, and string is the type. So has prefix takes an argument of string. Whatever string you pass in there, that's it. So that's a function, it takes in an argument. We'll come back to functions more. So go ahead and press enter on the one that says prefix here. And we pass in a string. Any string you want to look for. It's a prefix. We'll start out with AL. Right? So if my name has prefix AL, I'll just simply print a message. Hi, Al, right? Let's test it out, make sure it works. Hi, Al, right? That's great. So I'm able to find a prefix in any string using the has prefix method. Okay, this is a method here, has prefix method. Has prefix method. returns a bool whether the prefix in the string was found. Okay, that's good. Next, we'll see what suffix looks like by saying, actually, let me do it inline so we know we could do something else here. I could actually inline have a literal called questions. Has suffix. For the suffix, I will pass in IONS, and I'll say print. Did you put a print statement? Did you run after the if? Make sure you play in after the if. Here I'm printing all right, so here I have a questions string, right? Actually, let me take that out so I'm not confusing you guys. I will just create a message to and put message to here. Okay, so does message to have a suffix? Ians. Oh, yeah, ians. Does it have a suffix? Ians, right? In that case, let's see what happens. We also have onions, right? It does come in here. It does find the suffix. This is the suffix here. It could be ns, doesn't matter. It needs to end. What does the string end with? Right? I could simply have one character. Does it end in s? Everybody with me? Suffix. Prefix, same thing. I could say, does it have a as opposed to al? Or I could say, does it have ale? Everybody with me? Okay, cool. So that's has suffix and has prefix. Let's see what contains looks like. So this is has suffix. This is has prefix. And let's see what contains looks like. So contains, again, let's do on message. If message to dot contains element. You want to use the one that says character here. Contains element, character. Do we see that? Do we see that? Okay. So does this message contains this particular character? In the parens, you want to put quotes and whatever character you're looking for. One character. Not a string, a character. Does it contain this character? So here we will look for T, for example. Well, let's look for Q. And print message 2 contains Q, for example. Let's run it again. Indeed, message 2 contains the character Q. It does contain it. So we've seen ways to search for specific characters. Everybody with me? Keep in mind, as I said, we talk about big O notation in Unit 2. The runtime for contains is linear. So runtime for contains is, yes, it does. Is linear, or what's known as, I'll come to it, is linear or big O of n, written like big O of n or big O of n, this way. We'll talk about runtime more. But yeah, it looks for a specific character. So it goes through that entire string. and it brings you back the first occurrence of that character, right? So it goes through. Our comment here says runtime for contains is linear, meaning it goes through every element. Worst case, it goes through every element of the message. Okay? So the runtime here is n, as opposed to has prefix and has suffix, which has a faster runtime. We'll get more into runtime later. Everybody with me? Okay, cool. So I wanted to show you guys the way to search for stuff. And let us go to 2 more topics and we'll wrap up. We'll come back with a race tomorrow.
Only because I'm not my help too much.
Uh-huh.
When you're doing the name that has prefix and you're putting it in quotes, whatever, like it has to be capital.
Which one? Which one? This one? Well, if I'm looking for lowercase al, it needs to be al. Remember from Unicode, lowercase a is different from uppercase a. Different numbers, different Unicode numbers. So it's not going to be equal. Yeah, that's good though. It's good. Okay, so let us go to Terminator. It's in Terminator. Oh, let's go back to escape characters. So everybody scroll back up to where we did the escape characters because we haven't seen the tab. We've seen the quotes, but let's just see what tab looks like. So go back to escape characters. Escape characters here. So we did, oh, that's what we got derailed a little bit, the multi-line. Not bad though, it's fine. So we saw a new line example. Let us see a tab example. We could actually just tab on the same, yeah, let's tab on the same thing. So print, actually we can't, let's create a new string. So tab message, for example. Programming is fun, right? And here, if we go ahead and run our playground, well, let's first print out tab message. I'm going to print out tab message. I'll play my playground at line 41. Tab message will come up. Programming is fun. Everybody has programming is fun in the console? Okay, so assuming you want to tab now, right? You want to tab? You could use the escape tab character here to escape it, to tab over. So let's run it again. And now it's tabbed over. So right now, do you see where it is? Right, so that's a tab character, the tab escape character. And lastly, we'll see quotes again. Let's do quote. And we'll put in Swift was in 2014, Swift was introduced. And here, we want to put the 2014 in quotes here. Right? And the compiler is already complaining, saying, consecutive statements on the line must be separated. It's already confused. So let's fix it. How do we fix it? Backslash before the quote that we want to show, and backslash before the next quote we want to show. Now let's go ahead and print our quote. And we have our quote showing up as is. Everybody with me? And again, there's more escape sequences and characters. I will share it with us. Or if one of us do see it, just do share it with the class. But it exists. And we'll wrap up now with... Everybody okay here with escape sequences? Can I? Yeah. You're good. We good? How many people still typing? You good? Excellent. Let's go, 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 go. I will. Wow, a lot of code. I'll create a code snippet for this. Am I seeing a hand? Oh, you're just exercising? Exercise! Cool. All right, let's see some character traits. We haven't spoken about character by itself, but I want to expose some character properties for you guys. So here, some character properties. It's good. I did share the resource earlier this morning, but I will just show us character properties. I think as of Swift 5, it became way easier to work with characters here because of this. Okay, so say we have, let's do character 1. Character 1 is Y. Is this a character? Is this a character? Right, what do I need to do? Type annotate, right? Thank you, thank you. Okay, now this is a character. So on that character, I could say character 1, well, if character 1 is a letter. So on any character, you could have the property. This is a property. isLetter is a property, not a method. Methods have parents. Properties doesn't. So here it says, if character 1 is a letter, go ahead and do whatever you want, right? In that case, we'll just print a statement saying, saying Y, or saying string interpolation, character 1. Character 1 is an alphabet, for example, or is a letter, Right? So as of Swift 5, we have those nice little properties on a character, not F. Right? So we have isLetter. I won't do all the examples. We have isCurrency. For example, if you have a $, finding out if something is a currency. Currency. We have isPunctuation. Right? Example, a question mark. We have isNumber. Number. Example 3, 4, right? And one more thing I'll show you, or two more, and we'll wrap up in 10 minutes. Everybody typed out? We good? Okay. Let us see some useful methods in, I told you guys, languages don't die. NSString is an Objective-C API. No, sorry. No. Okay, so NSString is an Objective-C API. NS stands for Next Step. Next Step was founded by Steve Jobs, right? When Swift came around, everything dropped the NS, right? That's part of it, changing the language, making it simpler to write. But NS is still around. NSString is still around. And as I said, Objective-C is still around, strong. So here we have Objective-C APIs. API stands for Application Programming Interface. We'll get more into what APIs are. Application Programming interface. Cool. Okay, so let's have a variable here, call it, why should it be a variable? Oh, we might want to change it. Okay, so we have code in here, and code in is code in. So we have a variable called code in. And we got a question similar to yesterday, where question asks, I want to replace a specific character with a next character. In that case, I want to replace G, the character G, with the launch rocket emoji. How do I do that? All right. We could do it using a for loop, iterate through the for loop, find the character, and change it. We can. But we also have a built-in function. A built-in function is a function that's provided for us, like we've used before. A built-in function is print, has prefix, suffix. Those are built-in functions, meaning it comes with the language, right? Like you walk into a brand new house that you bought, right, from your developer money, and you have a built-in closet, right? It's there. You don't have to do it anymore. That's yours. It overlooks Fifth Avenue. It's a beautiful thing, right? So that's where we headed, right? It's built in. We don't have to worry about it. It's done. We just use it. We use that closet. Buy all the clothes and shoes you want. Cool. So here I have code in. I want to replace G. So on my variable code in, I put a dot. Anytime you want to access a built-in property or a built-in function, we use the dot syntax. The minute we use the dot syntax, let's back up one time. So put the dot syntax or dot on the code in, up comes all what's available to us. The compiler shows us everything that's available to us here. Do we see that? If you see a red strike through, that implies it's not available, or also it's deprecated. Deprecated means it will eventually come out of the language. Characters is no longer in the language. String.characters is no longer part of the language. Our labs were written years ago. Some of them still have dot characters in there. Does it compile? No. It's no longer part of the language. We have to update our labs. Right? Yes? I will change it right now. Yes. So if you see a strike through, avoid using it. Even if it compiles at the time, gives you a warning, please don't. That means it's eventually going to get out of the language. That's happening. So zero is like if you did a whole app, right, and all of a sudden stuff is getting deprecated, that's where you get most software developer money. You have to maintain that code. Keep it up to date. Take out everything that's deprecated and put the new APIs in, right? Job security. All right, so let's go back. So Luba is saying she wants to rename some names here. Too much coding. All right, let's see. So here we'll have whatever message for, and message for, and message for. Are you happy, Luba? All right, only one block of code in here. All right, cool. So on message for, we said, yes, question. Let me make sure I have message for here. Message for dot. Replacing, what's happening? My compilers. Message. Okay, so we want to replace, so replacing, you want to type in replacing. Start typing in replacing, and you'll see the APIs that's exposed to you, or the methods that's exposed to you. They're all marked with M. So there's replacing characters with some range. We want to use the one that says replacing occurrences of a string protocol with another string protocol. So the second one. Go ahead and choose the second one. Press enter. Right? Now we could put in 2 strings here. All good? Laptops are still working? No water? Okay, good. So here we want to replace G, well, yes, we still have G, with a rocket. So control command space and get our rocket here. Well, not here, but here. What's that? You don't have a rocket? Oh, you don't have replacing? Is your compiler auto-completed? When I say autocomplete, when you type in .re, does stuff come up?
Yes.
Okay, so look for replacing string protocol. The one that says string protocol. Let's go back. Okay, so .replacing. You should have replacing occurrences. Do you see occurrences? Do you have a string? Is it a string? It should be a string. Antonio, double check Julia's screen for string replacing. All right, cool. So here, Julia. So we have message for that replacing of replace G with my rocket. That's what I want. Yes, sir.
It's not going to work if you don't put rocket implementations.
Oh, sorry, I'm not done yet. Sorry. I was just trying to address. So here we have replacing occurrences of G. Wherever you see G, change it with a rocket. Everybody with me? Okay. So now, if I print my message for, now I have coding. We're going to the moon. Our developer skills are crazy. Right? So that's one built-in function still available in Objective-C. Okay? For now, I'm not going to go through the rest of them, but I will just show us 2 more, and I'll go to the documentation. So there's a way to... Actually, I have to show it. I'll show it. We okay here. We had a big lunch. Separated names. Separated names is my variable name. And my aim is to take my string. Let me create a variable or a constant called full name. Put in your full name. So I have a let full name. It has a string literal, your full name. And I say full name dot. So full name dot, start typing in components. Start typing in the word components, C-O-M. Scroll down or tab down to where it says components separated by some string protocol. Select that one, the one that says string protocol. So right now we have a variable called full name. We have a variable called separated names, which would really just be a constant because we're not changing it for now. How are we doing? Good? Okay, so now on full name, type in full name dot. Yes? Oh, that's fine. You could camel case it. So full name dot, and start typing in, as I said, components, C-O-M. Scroll down to the one that says components separated by string protocol. Do we see that? Do we see that? Okay, Luba?
Yeah.
Okay, and press enter. Now it expects some string. We put a space. So what happens? Alex Paul has a space. Do we see that? So this function says, hey, go ahead and separate the string into an array wherever you see a space. If I encounter a space, separate, break it up. Break up Alex Paul into two. Why two? One space. Right? One space, break it apart, put each part into an array. Adam? No?
You know, I think I'm not okay.
Okay. Yeah.
Said string when I put the component separated by string protocol?
Yeah, string protocol, yeah. Okay, so let's top down. We have a constant here. So far, so good? Let's go through it top down and then, yes?
So, let's say Paul's would it break your array up into three?
Say that again. If what?
If there was another name, like
What's your last name?
H-U-R,
H-U-R.
T-A-D-O,
T-A-D-O. Okay, we're married, right? I took your last name. Right? Okay. So right now, how many ways we're breaking this apart? 3 ways, right? 2 spaces, 3 items. Take those items, put them into an array. That's what that function does. Yes. At P, correct. Everybody with me? Whatever character you want to break it apart on, you specify it here.
So we're also everywhere we put a space.
Exactly, exactly. Everybody with me? Everybody with me? Okay. So what we get back, if you option click on separated names, what do we get back? What type is that? Option click on separated names. What type is that? I hear string, I hear array.
String.
People that say string, shout it out. People that say array, shout it out. Oh, so the arrays are nay, huh? That's why we're going to see arrays tomorrow, right? We'll see arrays tomorrow. We'll be more confident. We'll know for sure it's an array, right? What type is it? What type is it? It's an array. Square brackets, type inside the square brackets, array. No square brackets, type name, not array. In square brackets, type name inside, array. Genesis, close the lab. We'll do the lab tomorrow. The midday check-in. Yeah. That's one of the questions. Identify what array syntax looks like.
My question is, why on here when the left click it says separated names and then it's in the brackets it says string?
It takes a string.
It takes a string.
So Zara was bringing up a point. So what happens here? The right side of my equal sign, remember that always gets executed first. The right side of the equal sign, this here takes a string, correct? It returns us what? An array. Cool? So it returns us an array, and an array gets assigned to separated names. Cool? Very good question. So, give me a string, break it apart at wherever I want to break it apart, return me an array. I get back an array of separated names. How many items do I have in that array? So I heard 4, I heard 2, I heard 3, not 5, right? No 5s, right? Okay, how many say 3?
3.
How many say 2? How many say, what was the question? How many items we get in the array?
Oh, you'll have an Alex and close, Ricardo.
How many items? You'll be a politician now. Okay, so we have 3 items, right? 3 items because now I'm married to Hurtado, right? I took his last name. We have 2 spaces. We break it apart. We have 3 items. So how can we confirm how many items we have? Count, right? So I will say there are separated names dot count. Oh, there are 3 items. Right? So I will go ahead and play this. And I have correct for the majority wins. There are 3 items. Now let's print what our separated items looks like. So just print separated items, and I will print this. And do we see the console? Right, so as Tiffany was saying, now we have our items in quotes, they're each a string. So now we have an array of strings. We have an array of strings here. That's a good place to stop. Did you say that? That's a good place to stop. Do we have any questions? I want to show us documentation really quickly at the end of this lecture, just to see where things are. So, we all have laptops. We all have access to the documentation offline. Offline meaning away from the internet, away from internet access. If you want to read up on documentation for Apple's APIs, in Xcode, we have documentation. If we go to help, do we all see help here? Right? So click on help. Do we see developer documentation? Click on that. It opens up a window. Do we all see the window? Let me do it again. So I will close out of my window. I will go to help. Do we see help? Do we all see help? Help. So click on that. Do we see developer documentation? Click on developer documentation. Right? There's a lot of things there. There's like Xcode help, what's new in Xcode, release notes, right? RESTful APIs we'll get into in Unit 3, but REST is basically the way to query APIs, is the way APIs are written, web data, right? So click on developer documentation. Great. Do we all see the search bar? In the middle, up top. Click on the search bar. We've seen string, so type in string, the word string, type that in, press enter. So string, do we see string? Okay, do you see suggested results? Do you see one that says Swift Standard Library? Right, this one here, Swift Standard Library, the first result. Click on it. This is the documentation for the string structure, right? This here basically tells you what functionality you could perform on a string. If you have questions about strings, you could look at the documentation, right? It gives you an overview. It tells you what a string is. A string is a series of characters, such as Swift, that forms a collection. So it's a collection of characters. It shows you examples of the API, how to use it. In an ideal world, all Apple documentation should be like that. But that's not the case. But in the case where it is, it's great. This is a great resource. Shows you how to do multi-line, right? Shows you Unicodes. As a matter of fact, we should be reading this, right? So even if you see lecture, you see a video, you still want to read the Swift documentation, the string documentation, and see what's going on there. So there's a lot of things there, right? Performance, how to create a string. Go down to topics. Do we see topics? Do we see topics? Do we see topics? Scroll down to topics. Scroll down. Keep scrolling down. Or you could Command F to search for topics. Do we all see topics? Okay, so creating a string. We see different ways to create a string. We've used create a string with a character. How to test to see if a string is empty. There's a variable for that. A property for that called isEmpty. Basically, you say my string that is empty. It returns you true or false. We can't go through every single API, every single property and method. Impossible. But what do we do as developers? We see something new, we get used to it. If we have a question, either we go to Google, if we're in our basement coding away, we go to Google, we go to the Swift documentation, we go to the Xcode documentation, we could Command F, search for the thing, we could scroll, read about it. What's your question? Can what? Oh, Amani was asking, in our projects, can we use what's in there? You could use anything you wish. Okay? But do not use something you can't explain to the IA. Why did you do this? Never write code you can't explain to somebody else. If you got a piece of code on Stack Overflow anywhere, you can't explain it, give us the URL. Put the URL in comments. I don't understand this, but I wanted to use it. And we could go through it together. That's fine. Everybody got it? But never submit here or to an employer, prospective employer, some code that you can't explain. They tell you, come in, explain line 30. Why are you doing this? What's the other way you could do it? Is it optimized? Right? So be able to explain what you write in. So here, creating a string from Unicode, creating a string. So there's a lot of things here. Converting other types, creating substrings from URLs. We'll get into those things. Inserting characters, replacing substrings, removing substrings. There's so much. Lowercase, we saw that already. Uppercase, we also saw. And if you click on it, where the blue link is, if you click on it, it gives you a description of what the thing does. Returns a lowercase version of the string. That makes sense by the name. Right? You could go back, like in a browser, there's the back button. You could keep going. Comparing characters. So as we go through different APIs, try to get used to it yourself. Go through it, browse it. This is offline, doesn't need a web browser or web access. Reordering characters. There's a lot there. String is big, it's huge. Right, there's NSString here. We love NSString. It still exists. And before we stop the lecture, one more thing. Just search for array to get us ready for tomorrow. Search for the word array. Type in enter. You want to select the one that says Swift Standard Library. And this is array. By tomorrow, we all should be able to at least read the overview of what an array is, or what an array looks like. Gives us the overview of an array. An array is a collection of items, right? Accessing an array value. We've seen how to use a for loop here. It uses a for. And look at that. They're using the same way we're doing it. So get used to it. For street in streets. Right? A street is singular. For street in streets. If you could get used to this quickly, it's great. It reads very good. It might read a bit weird at first, like, what are you saying? Street in streets, I don't get it. But if you see it's singular, for street, one, in streets, many, many implies an array, then it's good, we get it. And if you see on the left side, do we see the left side on the column there in the navigation pane? At the top, we have app frameworks, correct? Do we see that? Let me zoom in. Do we see app frameworks? We see AppKit. We're not going to talk about AppKit here. That's like Mac OS development stuff. But we see Swift. We know Swift. We could click on Swift. Did we click on Swift? Did we click on Swift? It tells us about the Swift language, how to use it, how beautiful it is. We've seen int. We've seen doubles, strings, arrays. We're going to see tomorrow. Choosing between structures and classes. This here, structures and classes, you have to bookmark this. Every interview asks this on the phone. Well, almost every interview. What is the difference between structs and classes? Swift UI, right, for the leading edge. That's where we headed. There's WatchKit. There's everything there. Everything that you want access to as an iOS developer from the iOS framework is here in the Swift documentation. And one other thing, as we wrap up, if what you're looking for is not easily accessible here because it's hard to find it, Google is our friend. It is our friend. We could go to Google.
How do we bookmark?
We'll come around. So we'll go to Google. Again, Google is my friend. It's always the first I see. If I'm looking for something for Swift, I want to do something, I could actually type what I want to do, right? For example, remove, where am I? Behave. Actually, I could type it in the, up here as well. Remove, can we see my, let me zoom in here. Can I zoom in? Can we see what I'm typing in? I'm typing in remove somewhat here. Do we see that? All right. So here I could say remove or trim, whatever you want to do. Trim character from string, not Python, Swift. Whatever you want to do, put Swift on the end. Whatever you're looking for. I want to add two characters together. I want to add two strings together. I want to do something. Put Swift there, not Taylor Swift. Google has this massive search engine. It's very smart, right? That's why Google interviews are the hardest, because it's all about data. The minute my user is typing something, bring me the frequently searched results. Swift 3 was a frequent result. Okay? So here I say trim character from string. I put Swift. Trim character is not enough. If I say this is not enough. Everybody with me? I want to put the word Swift in there. You could even put Swift 5 if you want to be fancy, but don't limit yourself. Swift 3 strings, some of them still work. 2 still work, some of them. Yeah. So here, but don't limit yourself to 5. Just put Swift. Version numbers. Like iPhone 1, iPhone 2, iPhone 3, different versions. So here I have this, I get the first result. You might be curious, click on the first one, even if it says 2016. You click on the first option and start reading, start seeing what's happening. Look, this person is using some string here, string by replacing. Now that got changed, right? Because we have a shorter version. Every version tends to make it more modern. Let me blow that up a little bit. So here it says text2, which is a string, dot string by replacing occurrences of string. This is older. Older, very Objective-C. Objective-C was very verbose in writing the name of a function. Hey, string by replacing occurrences of string, right? But in Swift 5, it's a bit easier. What we did earlier. So here we have replacing occurrences. I'm done, right? As opposed to string by replacing occurrences of string. Everybody with me? Okay. So Google is our friend. Don't get scared to use it. Start using it for whatever you want to do in your game or whatever. The documentation built into Xcode is also helpful. If you want to go to the browser, you could also quickly search for documentation. I could say string, Swift, enter. And the first result is the Apple documentation online. This is the exact documentation we saw in Xcode, right? So it depends on where you are or how fast you want to, whichever one you're more comfortable with. So they're all there for us. Cool? All right, great. Thank you.